A Venn diagram to deal with here, and we're asked first of all to state any pair of mutually exclusive events from A, B, C, and D. So mutually exclusive is when there's no overlap, they cannot happen at the same time. So I'm just going to go with A and C. But I could have gone with A and D. I could have gone with B and D. So I think there's three options here. We're then told that the events B and C are independent. Right, what that means is the probability of the intersection B and C is equal to the probability of B times the probability of C. This actually, by the way, comes from the more general formula that you have if the probability of B given C is equal to the probability of B and C over the probability of C. But if they are independent, then the probability of B given C is the same as the probability of B given not C. That C doesn't matter. And you just times through by C, and this gives this formula. I just wanted to say that. I haven't, of course, explained where this comes from, but that's for another time. That's our conditional probability formula. So we can use that here to find the value of P, because the probability of the intersection of B and C is 0.27. Actually, let me write, I don't want to get in the way of R. So 0.27, and that's going to be the probability of B, which is these three added together. So that's going to be P plus 0.32 multiplied by the probability of C. That's all of these added together. This gives 0.6. And now I can divide through by 0. I mean, you could expand the bracket, but better to just divide through by 0.6 minus the 0.32. We get P equals 0.13. And actually, I'm gonna update my Venn diagram and put it in. Now, we're asked to find the greatest possible value of the probability of A given not B. Okay, well, I sort of quoted that formula before. The probability of A given not B is going to be the probability of A and not B over the probability of not B. So the intersection of A and not B is going to be everything in A but not in B. So that's just going to be Q. And then the probability of not B is going to be Q plus 0.33 plus R. So 0.33 plus Q plus R. Okay, so we've got to try and maximize this. One thing I've not yet done, I probably should have, is I could actually work out what Q plus R is equal to. Because we can add up all of the other probabilities that we have. So we can do 0.05 plus 0.13 plus 0.27 plus 0.25 plus 0.08. And we can do 1 minus that. And that must mean that Q plus R is 0.22. So this is good because now it's going to be Q divided by 0.55. Now, if I want to make this as big as possible, so max probability A given not B, then I need to make Q as big as possible. And the smallest it could be would be 0. That would be as small as it could be. But yeah, I want the numerator to be as big as possible. So that means I basically want to say that it is the 0.22, and actually R is equal to 0. It's going to be 0.22 over 0.55, which gives 2 over 5, or 0.4. Yeah, good question, that one. Now we're given that the probability of B given not A is 0.5. We're asked to find the value of Q and the value of R. So forget part C, that was just to maximize that probability, but now we're given this extra condition. So it's going to be the probability of B intersected with not A divided by the probability of not A, that's going to equal 0.5. B intersected with not A is everything in B that's not in A. That's going to be these two, so 0.4. and then I'm dividing by everything not in A, that is going to be the R and these, sorry, lots of circles going on here, but these four added together. So 0.13 plus 0.27 plus 0.33 from those two plus R, we're going to get 0.73 plus R, and that is going to equal 0.5. So I can rearrange this. 0.73 is going to then equal 0.4 over 0.5, which is going to be 0.8. I forgot about the plus R, sorry. And hence R is going to equal 0.07. We know that R and Q add together to give 0.22, so Q is going to be 0.15. Next up, we're asked to find the probability of the intersection between not the union of A and B with C. Okay, well, let me just get rid of this and let's work through this really carefully. I'm also going to add in that this is 0.15 and this is 0.07. So let's take it step by step. I'm just going to, first of all, okay, I'm just going to focus on C. C is going to be the easiest one to deal with. So I'm going to put little pluses where any part of C. So these three here. And then I think I'll do red crosses for not the union of A and B. Well, the union of A and B is everything here. So if it's not that, then it's the other three. It's going to be this, this, and this. And then I'm looking for the intersection. So I'm looking for where I have a blue plus and a red cross, because that is where it's in the complement of the union of A and B. That's not A union with B and with C. So I just need to add those two together and I'm going to get 0.33. And finally, we're asked to use set notation, just like in E really, to write an expression for the event with probability P. P, that was this one here. Okay, I'm going to do it up. No, let me do it a bit down. So, okay, I just about fit it in. F. All right, so when I did it, I said I want the probability of B, but then I want to get rid of that 0.05 and the 0.27. So if I take B and I try and cut out that 0.05, I could do, for example, the intersection with not A. Because if I did B intersected with A, that would give me this bit, but B intersected with not A gives me kind of the stuff in B that's not in A. Right, now I'm left with 2, but I can do exactly the same with C. I can then also intersect it with not C. And I'd say that is the quickest way of doing this question. So if you want to cut things out, just take a bigger group and then start intersecting with not the set, and you'll be there. There are other answers to this. They amount to the same thing. You could find the union of A and C and then do not that, and then intersect it with B. This is the one that I did, or you could intersect B with not A, intersect B with not C, and then intersect it all together. There's other things you could do as well, but I mean, mine's second on the list, but I think that is the best, the quickest one to go with. Well done on your efforts on this question and on the whole paper. Lots of things to take in from this Venn diagram, but I hope it makes sense.